Okay, when I explain this, you're going to say this can't possibly be, it can't be this simple, but it is. Light is literally the electrons that are in the cloud surrounding the nucleus being so vibrated and so excited that they escape. They have escape velocity. Bing! They go flying off of the surface of this sphere, just exactly the way a missile does off of the Earth. And they, at a certain escape velocity, which is the speed of light, they spin off of the surface and they go floating through space at that speed until they collide with matter. And when they collide with matter, they exhibit their energy, the light and the heat. So when they come into another molecule or atom such as this, and they come in and they hit, they literally bounce off of here. Some of this will vibrate and shake into creating heat, and the rest will bounce off as light. And I'll show you a graphic of that. It's not anything high definition, but it should explain it. Before I go too far into this, I just want to show you. This is my background. I've done this for years and years and years. It's something that I'm not just guessing at. It's stuff that I've done for years, and I know this stuff very, very well. And these books are full of these things. It's not, I did this on a weekend or something. And I've done all the calculations of, you know, the energy levels and all kinds of stuff. The power generated and the different temperatures and all of that business. So I'm not just guessing at this. Now, here's what I'm talking about as far as the light given off by the sun or any star. Now, literally, here's your atom. Okay, so here's your atom, and that's the cloud, and the electrons spin off just like this. Boom, they go shooting off of here as they get excited, and that little black dot is the electron. They spin in this circular pattern away and through space, which has no nuclear bits that have clouds. So in space, all you have is these things shooting around. And then occasionally you'll have some full matter which contains a nucleus with a cloud. And when that happens, this comes in and boing, and it bounces and penetrates and goes flying off in space, or this starts to shake and heat up. That's all light is. And that's what energy is. And here's what happens is from the star, or our sun, we know that it's coming from there. There's no question about that. It comes out of there spinning like crazy in every different direction, and we just can't see it. It hits the earth. It's dark energy. Here it is right there. See it? You didn't know it was there. There it is. And you can't see it because it's not hitting anything to exhibit. That's all. It's as simple as that. When it gets into the earth has all this kind of stuff around it, and it has nuclear material, and it has clouds of electrons. When it hit it, it bounces just like a super ball. That's all there is to it. Now, and those are vortex particles. They're not what they think of as light is now. It's totally different. It's an electron spinning just like I showed. And when they spin, they come through space, and I have a full video on this. Rodney Warren has done experiments, fabulous experiments, photoed all this kind of stuff, and there's very, very little possibility that it's not correct. Anyway, light is dark energy in space. That's all it is dark energy and dark matter in space. And until it impacts with nucleated electron clouds, and that's when it creates its heat and its light and its energy, and that's when we see it as energy. And there's no question, it has to be energy in the middle. It's not nothing. It leaves out of here as energy. It hits solar sails, pushes them, makes things move. It hits the space station, lights it up. It creates food in space. It grows plants. It's energy. It's particles. Those particles actually hit the earth, and those particles have a weight, and those particles are spinning electrons, and they're free spinning electrons, and they weigh 0.00055 atomic mass units, which has weight, and the energy is the mass. And then you take the average amount of watts per square meter times the electrons in a watt, and then times all of this stuff. you know, there's 1,000,000 square meters in a kilometer, and there's 510 million square kilometers on Earth. Multiply all that stuff out, the Earth is growing by that much every single hour. So this is what I'm saying, and I have a video that I'll show you in a second that displays all this quite clearly. And then it shows it in pictures. I mean, we actually photographed this, Rodney, and I'm doing the same experiment here. And it's hard to understand. Well, it's not hard to understand once you understand it. That's the key. You just have to understand that it's an electron. It's not some magnetic wave, and sometimes it's a particle, and sometimes it's a wave. No, it's crazy stuff. It's what it is. It's just the simplest thing that there ever was, really. It's just a little particle spins like crazy and it hits another particle and it bounces. And if it doesn't bounce, it creates a vibration that is heat. And we see it as light. Alright, these are the videos that I have about this light study, and there's a bunch of other stuff out there. There's a mudfossils.com is this channel, and this is some of the light that I was just talking about, and that is a light disk being sucked through a Venturi slit, which is two round orifices. It's an orifice created by two round pillars, and the light goes through it and creates this shower of atomized particles, and that is exactly identical to what happens in a carbureted vehicle, of an older style car, where the gas was sucked through there to create atomization, which allowed it to be burnt and combusted. And that is identical. It's not close, but there is no difference. None, zero. So I am saying that light is most likely a fluid, and it exhibits every single fluid characteristic there is. And there's other things to look at here. This is a vibrational patterns of the rule of 8, which is also applies to you know, the light being bounced off. And then it goes into some of the experiments that we did. And anyway, that's it. That's what I want you to see. Alright, at about 3:15 or so on this same video, one of the first videos showing that atomized spray, I show what it appears to be electrons. And as we come through this video, it goes in, here they are in a vortex spray, and they show up for 2 wave cycles. And I have some other ones in red, and this is a regular wave pattern. And that's in midair, and this is light screwing right in. Look at this. You can see the actual screwing in of the light through our vortex. But anyway, look at those other things. I don't want to bore you all this stuff, but there's a lot of information here.